Hi, and welcome again to Combustion Discussion. This is our third video, and today we're going to talk all about custom ECU tuning, and in particular we are going to look at it from the standpoint of a consumer view, that is trying to educate you, you're the consumer, you are the viewer, but also the consumer of ECU tuning services, and we're trying to make you into a smart shopper. So the first thing, today we're going to talk about what happens when you have your car ECU reprogrammed or tuned, what kind of tuning options are out there, and how to find a tuner. So I'll start talking a little bit about what happens when you buy ECU tuning, and the standard you can maybe pick up from there. We were talking earlier that ECU tuning, choosing a tuner is a little bit like finding a physician. Mm-hmm. So, and there are other parallels too. When you go to get your car tuned, it's almost like when you go to the doctor's office and they put you on a treadmill and you run to do a stress test on your heart. The chassis dyno, which we have one in the back, I'm pointing to it, it's kind of the same. We run the car hard on the dyno and we find out how it behaves, and we get feedback from the car. Is it happy? Is it healthy? If it is not, we can correct problems, or we can also increase the performance of the car, but within safe limits. So in that sense, your tuner can be kind of optimizing the performance of your car, as your doctor may tweak your health to get you to your maximum performance.
Another important thing to notice about that is that like going to a doctor, being on a dyno provides you with a quantitative measurement of how the health of your engine or your car, depending on how you look at it. Another interesting thing that we wanted to note with regards to the doctor visit that's similar to what we do here at Mach 5 is that we use a dyno to quantitatively measure the health of your engine. It's quite similar to going to the doctor's office and getting a blood pressure readout. He or she, the doctor, will know that you are either in good health or you are in questionable health. The dyno is a very important tool for that, in that we can make changes to an ECU or the engine, or just generally evaluate the health of the engine. And we can get a repeatable measurement of the health of the engine. That is particularly important because without repeatability, there is no reliable change. That's a key thing we'll get into later about the advantages of dyno tuning over any other type of tuning.
That's an excellent point, though, about kind of the parallel of the doctor getting quantitative data and us getting quantitative tuning data from the dyno. There's sometimes customers come in and say, I don't think my car is running right. And we can peek into the ECU, or we can run the car on the dyno and say, actually, it's in perfect health, it is behaving completely normally, and your perception was not right. It's running fine. Maybe you're just used to the big power now and you need to buy more things to improve it. But other times a customer may come in and say, gosh, between 3,000 and 4,000 RPM, it feels like it's falling flat. And we may actually find that he's right, that maybe there's some timing retard, or maybe there's a leak and boost is falling off. So the scientific measurement tools that we have can prove or disprove a hunch or a feeling and turn that into an actual calculated measurement. And to me, that's super important. You can do all the tuning and tweaking you want out in the real world, but if you don't have a measurement, then you may be wrong about it.
Yes, science.
Yay, science!
Okay, another thing that we'd like to speak about is reprogramming of the ECU and what actually that's doing. So the access port is a Cobb tuning product, and it's very common throughout multiple makes and multiple years and multiple brands of car.
Should I list them out?
You can, Dan.
All right, sure. I'll list them out. I think I can provide a complete list. The access port, I'm going to spell it out on the screen so you won't have to try to understand it from my own talking. But It's available for all turbo Subaru cars, from 2002 WRX all the way to the current brand new 2015 WRX and STI. I think that's not out actually as we're filming this, but probably will be very shortly. It is available for the turbo Ford Fiesta and Focus cars, Focus ST and Fiesta ST. It is available for the BMW, thank you. It's available for the BMW N54 and some of the N55 cars. Of course the GTR, Godzilla. I love it. It's a fantastic tuning platform for the Nissan GTR. And the latest addition to the access port family is for the Porsche Turbo 997, both .1 and .2 versions. Even a GT2 we can reprogram with the access port. I got a few of those on the shelf, so Porsche Turbo guys, give us a call. I think there was one more I wanted to talk about. Yes, the Lancer Evolution. So there's also an access port for the Evo 10. It used to be available for the 8 and 9, but that is a discontinued product. It is still available for the Evo 10. I think I have an access port. Maybe we should show it.
We should.
Okay. Alright, so still rolling. So through the magic of video editing, I've instantly materialized a laptop computer and a Cobb access port. It's plugged in so you can see the screen, and it's got a OLED screen on it, kind of is the size and shape of a smartphone, and it's a pretty amazing little device. So there you go, Cobb access port.
So with the Cobb access port, after we have now heard every make and model that Cobb supports, it's really quite fascinating actually. The access port is basically a user interface that allows you, the user, to write new hexadecimal code to an ECU. What is hexadecimal code? Hexadecimal code is basically the base language that all car computers I don't want to say all, pretty much all car computers use today. ECUs vary in size and shape, basically version, software, and it's a very large feat once you break it down that Cobb has been able to make all of this stuff accessible for a user and tuners like ourselves.
Remind me, what does ECU stand for?
ECU stands for Engine Control Unit.
Thanks.
Yep, and there are different ways to, not all cars have an ECU. BMWs, for instance, have a DME, which is Digital Motor Electronics.
Wait, but is it a different thing than an ECU?
No, they function exactly the same, for the most part. They all process the same signals, and they all output the same things, with just various hardware differences and basically strategical differences. For instance, direct injection versus port injection.
But you're saying that a DME is the same thing as an ECU, it's just a different name.
Yes, I am saying that.
Okay.
So it also varies by manufacturer. So Bosch ECUs are often called ME, which is just motor electronics. So there's different ways to label it, but for all of the purposes of this video series, we will call the computer that controls the engine in a car an ECU.
That was cool. Also, lightning happened right when you were finishing your sentence. It's like a monsoon outside. Yeah.
Yes.
This is show me the magic. Okay. So that's what happens. So to summarize, when you reprogram the ECU, we're going to basically overlay new computer code on the car's computer. And what exactly is that different code going to do?
That different code is going to provide different control instructions for the computer. And what that means is that, for instance, if the engine's computer, or the ECU, is telling the engine to create 10 pounds of boost at a certain RPM, if we change the code, we can, in a simplified fashion, tell that computer to target 12 pounds of boost at a given RPM. This will make more power, theoretically, and allow us to quantify the change on our dyno. This is sort of the basis of what tuning is, at least one variant of it.
Pretty good explanation.
Thanks.
All right, so that's kind of the general idea of what happens when you do an ECU tune, but I want to get into a little more detail about what parts of the engine computer's program will change when we retune a car. There are quite a few parameters or numbers that can change, but the basic categories, it breaks down to 3 categories. There is fuel, timing, and boost. For turbo cars, there's those 3. If you don't have a turbo car, you only got fuel and timing. But most of the cars we work with here at Mach 5 are turbocharged, and most of the tuning we do is going to involve fuel, timing, and boost.
Don't forget camshaft advancement, because that is...
That is true. That is increasingly common on today's engines. Okay, but lest you get the idea that ECU tuning happens in isolation, I kind of want to talk about that the car is a system. And when you're tuning a car, you are not tuning a single program. You're not simply adjusting one bit of the car. It's an entire system and it works together. If you don't optimize the whole system, you will have problems. And so I kind of want to address, I want to address that the system works together. If you adjust one thing, you are likely changing other things, some of which you might not anticipate. And so when we are doing tuning work on a car, I'm sure you know what I'm talking about, that you can't simply turn up the boost and leave it. You can't simply advance the timing and just walk away from it. It's much more complicated than that. And a properly tuned car will have all of the tables adjusted in a coherent way, a way that works together. It keeps the car safe, reliable, but hopefully gets you a better power output, which is kind of the whole goal of our tuning process, than it would be if it was left alone. But that also points out that this activity can be dangerous. If you do it wrong or badly, you can have a worse result than when you started. At the minimum, I guess you would have less power than you want, and at the worst case, you might actually damage or destroy the engine. So tuning is a holistic process. You have to think about how the hardware and the software interacts and how all the factors of the engine interact, the fuel, the timing, the boost, the cam position, and more, things that we will go over or have gone over in our other videos. So it takes a while to learn how to do this. I guess that's one of the things that we will probably say a few times. Sandra and I have both been tuning for a lot of years, and we don't know everything yet.
Yes, nor will we ever, I think, in the most part. It's such an interesting time right now with regards to tuning and engine management. As Dan had mentioned, there are so many things to keep in mind when tuning an engine. As Dan mentioned, boost, fuel, timing, camshaft advancement. But these are all interrelated variables. So, for instance, an example I can think of is a Honda K-Series engine. Certain models have a 50-degree camshaft advancement gear. This doesn't have to mean anything in particular, but the way that the factory ECU is tuned is that it is one fuel and one ignition table for every 10 degrees of advancement. So what this means to you is that if there was an engine that a normally aspirated engine with no turbo, if there was an engine with no camshaft advancement, you would be tuning a fuel table and an ignition table, and that is at the most basic part of it. That is it. Now, the way that the K-Series engine is designed is that you have to tune a fuel table and an ignition table for 10-degree increments from 0 to 50. That makes 6 times the work of a normal tune. So you would be tuning a car at 0 degrees, tuning the engine at 10 degrees, tuning the engine at 20 degrees, tuning the engine at 30 degrees, so on and so forth, until you create the best power band over all 50 degrees. That doesn't even have to necessarily make complete sense at this time, but it's really important to highlight that there are so many variables to keep in mind when tuning an engine. It is never as simple as Dan had stated, just turning up the boost and then calling it a day. It's turning up the boost, keeping an eye on the ignition feedback and knock, keeping an eye on the air-fuel ratio, making sure that all of these variables are in line at whatever variable that you decide to change. So it's a really multi-dimensional process, and I think that while we don't want to make the process seem scary, we do want to highlight that it is quite difficult to do it correctly. It's very easy to do it wrong.
And I'm glad you touched on the thing about the multiple tables for different cam advance situations. In general, we have seen over the past decade, I would say, we've seen sort of a exponential growth in the complexity and sophistication of engine management systems. Back when turbo Subarus first came to the USA, 2002, the ECU was an 8-bit computer. Then in 2004 or 5, it turned into a 16-bit computer, twice the complexity, twice the code size, twice the memory. In 2008, it went to a 32-bit computer. It doubled again in the complexity, the capabilities, the speed of the ECU, and the number of tables available to tune. This is great because the cars can do amazing things. They can make more power, use less fuel, and have more flexibility. But from the tuner standpoint, the challenge increases along with it. So this is both an exciting time and a difficult time to be tuning, as the ECUs continue to advance and we tuners have to keep up.
Yep, very much so.
All right, you want to talk a little bit about the process of shopping for a tuner?
Sure. Well, shopping for a tuner is a very difficult, task. As tuners, Dan and I, we are fortunate in that we share a lot of the same principles in tuning cars. What is important when you are shopping around for a tuner is that you ask questions. Mainly, experience is really paramount. That cannot be overstated. While I can think of any number of problems that I've run into over the past 10 years that sort of have been added to my knowledge bank of diagnostic practices. For instance, I had a Honda on the dyno the other day with an F-Series engine, which is an S2000 engine, and a centrifugal supercharger. This car kept losing power just a little bit at a time, 5 horsepower at a time, every pull. And I checked my fuel settings, my ignition settings, everything was as it was, the data logs looked perfect, there was no sign of anything amiss.
Can I guess what the problem was?
You can, Dan. What was the problem?
A boost leak. It's always a boost leak.
It's always a boost leak. Yep, that was the problem.
Okay, so you mentioned about experience.
Right.
I firmly believe this is one of the most important parts of finding your tuner. And I'm not just saying that because I've been tuning for more than 10 years, and so have you. But, okay, so there was a scientific study I read about. Somebody can maybe reference this in the comments or something, but it was a study of heart surgeons, and they basically were looking at how successful the surgeons were in terms of how long their patients, or how many of their patients, survived heart surgery. Heart surgery is kind of dangerous. The short answer is that the surgeons that had done the most surgeries had the best survival rate of their patients. And in fact, the surgeons who did the most per year, the most frequent surgeons, had the best survival rates. So find a tuner who has done a lot of tuning and who tunes daily, a lot. That is going to be a lot better than a person who is new and who only tunes once a year. We both talk about this all the time, that once you kind of get into a groove, you remember things, you know a workflow, and it becomes second nature. You are efficient and you can remember to, how to avoid certain pitfalls. And if you set it down or you don't do it all the time, those pitfalls are much easier to fall into.